Okay, Bismillah. I would like to implement these classes, movable circle and movable point, and interface movable. First of all, just to remind you, whenever you see these dashed lines with this triangle, this means it's not inheritance because we inherit from a class, but it's implementation of an interface. So which means these two classes are implementing the interface movable. And of course, this is the place where we put the instance variables, but there are no instance variables because interfaces do not have any instance variables. But they may have what? Well, these are they will have to have at least an interface, have to be at least having one abstract method. At least one will make it an interface. If you have an interface with 0 abstract methods, well, you need to have something else, or this interface doesn't need to be there. What is that something else? What can we put here? Can we have instance variables in interfaces? No, we can't. But we can have something that doesn't change, which is a constant. An interface can have a constant variable, a final variable, that if I put a value inside of it, it will never change. That's what I can find in an interface. I can find constants or abstract methods. And by default, they are public and abstract, even if I don't type it down. So even if you see these pluses, I'm not going to be typing plus, because by default it's going to be public. So I don't need to put it. But they're here, they are there. And this symbol here, do you remember what this means? This is a symbol of composition, which means this class is composed of this class. Which means this class is part of this class. It is used by this class. Movable point is used by movable circle. And you can see here that the center is of movable point data type, which means that this movable circle requires this class in order for it to work. If we don't have this, you cannot define this class, because it needs the movable point before you can work with it. So that's what this is representing. And this one over here means this movable circle includes one movable point. I can have other cases when you have more than one or whatever, but this is the one, this is what it means. So I'm going to be implementing, defining all these, and let's start. I created this test movable where I'm going to be having my main method there. So I'm going to leave it there, and then I'm going to create the first thing that I'm going to create is the interface, because everything is going to be based on it. So let's create an interface, and we call it movable. I don't have to give it this able at the end, but it's better if it's an interface to give it some kind of either an action, if it's an action word, or like an action verb, or a movable, which is representing some sort of able, which is doing something, an action or something. So let's click this. So we have the interface, and all I need to do is define this move up, move down. All of them are void and no arguments. So void, move up, and copy paste down. I don't need to put it because it's by default it's going to be public. Right and left. And let's close this, we don't want these disturbances. Okay. Save your changes, whatever. Okay. Anyway, because it's an interface, it's going to be public. And you see this icon? If it was package, I would see the package symbol over it. And you see if I put my mouse over it, you see public void move left, even if I did not mention it. So by default, in the interface, there is no thing like package, protected, private. It's public. So that's it for this class, for this interface. Now I'm going to create a class. Which one should I start with? Obviously, I need to start with this one, because movable circle is using movable point. So I need to start with movable point first. So movable point. Yes?
Don't we need to make the methods abstract?
No, because if it's an interface, they are abstract. So you don't need to put public, we just said it, but you still don't need to put this abstract because they have to be abstract. So putting it or not is the same. It will give you the same result. So because we're lazy, we just don't type it. But if you type it, خلاص, you can leave it. It's the same thing. It doesn't change. This or that is the same thing. Okay, just for consistency, let's just remove all these. And you understood that they are now public and abstract. Now I need to implement movable. And implements movable. Now as soon as I said that, it will tell me, well, your class is not respecting now this implementation because you have two choices: either implement all abstract methods or make the movable abstract. Okay, so that's the thing. I'm not going to be touching it. I just would like to go back to the questions so I can follow up with that. So this is our class interface movable, and then we wanted to have this movable point which has these instance variables. So I'm just going to copy these and then maybe just make some changes later on. So these are the instance variables, and they have package access because I'm not putting anything, as opposed to the interface. They will be having public and abstract, but here they are going to be packaged because this is a normal class and a concrete class, so I need to do that. And you got the point. I mean, I can have this, and by the way, I'm going to use the alt insert because it's much convenient. Just click constructor and select them all, and it will generate the code for me. I don't need to type all these things over there. So this is my constructor that takes 4 arguments, and all of them are initialized. Now I need to implement the abstract movable and so on. Also, the toString. Let's just insert the toString right away before I forget it. Okay, alt and insert, and the toString, and select them all, and then it's going to show this to me. I don't need to do anything else. If I want to customize something, I will, but I don't need to. Now let's implement all these abstract methods, and by default actually it adds this code for us. This code, what it does, actually it throws the exceptions, and we're going to talk more about exceptions, what are they and how to work with them. But just this will do something. It generates this for you, but it adds something that if you by mistake you generate them and you forgot to implement them, once you call them, these methods, it will give you an error, an exception. For example, I just did this insert. Try to define all these abstract methods, right? If I leave this here, what would happen is that let me just test it for a minute. Movable. Okay, just movable point mp equal new movable point, and it's going to give me 5, let's say, and then 5, 9, 8, whatever. Now what happens if I do mp.move down, whatever? Now if I forgot to implement it, NetBeans actually helped me, but also put something so you don't only rely on just generate everything and then forget to implement it yourself. Now if I do something, look what is going to happen. An exception was thrown at this point here. So this actually generates an exception. This is what it means. This is going to generate an exception. So in case you just forgot to implement it yourself and just click the button, generate all or implement all abstract methods, and then you moved on to another class and keep going, it will not work because it will generate some errors, some exceptions. So anyways, we want to now do something. We want to do something in the move up that goes, in the opposite direction of the normal axis. The y-axis is pointing down, so that's why we're going to be Okay, I just did something. I don't want to do it. Okay, let's do something like this. Okay, now Control S and then Alt Shift F to format, and everything is formatted now. But this is down. Is this down? This is the code for down. This was the code for up. It was meant for up. So this is for up. For down, it's plus. Okay, so for here, what I need to do? X, move right. I need to add. So X speed. And to left, I need to subtract. Because I'm moving left. And subtract. Okay. Is it over? That's all I have? So the toString, yes, I just added it. I added this movable, the constructor, the toString, and then I implemented the 4 abstract methods that came from the interface. So I'm done with this movable point. Okay? Now going for the movable circle. In the movable circle, it implements movable as well, and then it's going to complain. That's fine. And let's go back to the questions so we can see what is needed as well in here. The same thing where the instance variables are going to be 2, and the constructor that I'm going to be generating. The constructor, let's go back here. So this is the movable point. This is the one that comes from this class. And now I need to generate the constructor. Alt insert constructor, all of them. Okay, and then you see it's going to do it for me. Movable circle, movable center. But this is not what I want actually, because if you look at here, I want to supply the x, y, and speed, x speed, and y speed, plus the radius. And what it generated for me, just the movable point, and then this. So I don't want to do this. I would like to have something like these values. So I need to do it then myself to adapt it to whatever I need.
Yeah, so why implementing center? Why doesn't implement x, y, x speed, y speed?
Because it just tries to help you with the easiest way, the most obvious way. The most obvious way is that you just supply a movable point, and then this movable point is going to be saved into this center, which is the of type movable point. Like what you give radius, we have only 2 instance variables. That's why it just prepares only 2 arguments. But if you don't like this, you want to have something else, which that's what we do, then we need to adapt it to what we want. So now we are adapting it to have like this 4 and then the radius. Now I cannot use something like this. I need to do some new, and maybe just copy if it's ready. Something like this, new movable point, like this. Now this, I'm just taking these values and send them to this constructor of movable point, and the last one for the radius.
It doesn't matter if you write this center or just center equal.
Of course, because there's no way to have like an ambiguity. There's no such parameter called center, so we can just leave it like this, or add the this. It doesn't change. However, for the radius, I have to put the this. Yes, because I'm using the radius as an argument. Okay, so we have this, and then what we wanted to do again is also the toString. So the toString, let's just implement it. Alt insert, and then the toString. Yeah, so it's going just to show me the center is, and of course this is going to be calling the toString from this. This is going to be calling the toString from the movable point, and that's fine. The center is going to be a movable point, and etc. and so on. So that's fine. It works fine for me. Now let's implement all these abstract methods, and basically they're the same, except like I'm not moving like the point, I'm moving the center. So actually what I'm going to do, let's copy from here. I'm going to copy this and adapt it to whatever I need to do. And let's copy this from here. Except that I don't have x right away, but then I have something that can be taken from the center. And the same thing, that's what I need to do. Because center is a movable point, and I can get that from there. Is it okay? I can do something else. I can do something like this, or what about this? Call the one there. Call the one from the movable point. It will do the same thing, right?
Yes. Yeah.
Because what was here before, let's just leave it there, for example. Okay, I lost my cancel. Whatever. Okay. Okay, what I had here before. Let's have a look at this one. So you have to be able to do this kind of comparison. Look, move up here. This is move up, and this is move up here. What it takes is just center.y minus equals center.y speed, right? So this is the same thing as y minus equal speed, except that I'm going to this class to do it. So if I'm calling movable up here, move up, it's going to do the y minus y speed in the center. So if I just, instead of doing this, I just do this, move up, it's going to move up the y in the center, which is the same thing as you put center.y plus equal minus equal center.y speed. It's the same thing. So I can do it this way as well, which is much more, I think it's better because it reuses the code instead of just doing it yourself. And instead of, I'm not going to be just copy and paste. But you can leave it to as what it was suggested. It's up to you. But I just prefer it looks cleaner this way because it's already defined there. And then if I would like to change the way it works, I can just change it in one way, and it's going to work anyways. So that's all I need to do now. And I have finished all these. The last thing I need to do is just to test this code. I just corrected the code that you had before. We added extra arguments because I think that's why you had some problems before. So now let's go to the main and then paste it here and then run. It says upcast. Why does it say upcasting? Because this is movable point and I'm putting it into a movable. I'm using the movable interface as a type. So I'm going from down to up. It's possible. That's why it's upcasting. And now, even if it's an interface, you see, M1 is an interface, right? Movable is an interface. But because it's being used to have a movable point inside of it, if I call something, this move left is going to be the move left from the movable point. Or if I call this any move right or any toString, for example, here, this is the toString from the movable point. So that's why it's going to be doing the right calls. So let's run this. And I can see that this is the first call, 5, 6, 10, and 5. And then now when I moved left, it became 5 minus 5, 6, 10, and 5, the movable point. Now for the circle, 2, 1, 2, 20, and put 20. So I have this movable circle. The center is a movable point. That's 2, 1, 2, 20. 220. This is the speed, and this is the radius. And the radius is 20. Let me maybe can I zoom out a little bit? Okay.
Why? When we move long to be x equal 4.
We move right. We move right by 2. Sorry, this is the x, the y, the x speed, and the y speed. So I moved right by 2. That's why actually it's from 2 to 4. That's why I have this. So it was 2 before. I just want to make this spanning the whole thing. So I can see now it was 2, but because I moved right with this speed of 2, then it became 4. 2 plus 2, 4. If I would like to use the y speed, let's say move up and then move up, so move right and move up. Now what would happen? The y is equal to 1. If I move up, it's going to be the minus, right?
Minus 90.
So let's run. Now it's 4 and minus 90. So I moved right and moved up, and this changing the things. Okay? Everything is clear, Shalom? Any questions?